data structure, we are going to learn the concept. So let's define. ಮೊದಲು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಣ data structure ಅಂದ್ರೆ ಏನು ಅಂತ. Okay. So data structure is nothing but well organization of data. Okay. Well organization of data. For what purpose? Its purpose is to have the proper memory allocation. We are going to give for the memory. Second, accessing easier. Accessing is easier. Searching is easier. Searching easier. For future modification and alteration is easier. Updation, modification and updation to be easier. Simple terminology you can take for your mother kitchen. Kitchen. Okay. ನಿಮ್ಮ ತಾಯಿ ಯಾವ ರೀತಿ ಜೋಡಣೆ ಮಾಡಿಟ್ಟಿರ್ತಾರೆ ಅಡಿಗೆ ಮನೆಯಲ್ಲಿ ಅಂದ್ರೆ ಅವ್ರ ನಿಮ್ ತಾಯಿ ಕೇಳಿದ ತಕ್ಷಣ ಶುಗರ್ ಎಲ್ಲಿದೆ ಅಂದ ತಕ್ಷಣ ಅವ್ರು ಶುಗರ್ ಬಾಟಲ್ ನ ತೆಗೆದುಕೊಡ್ತಾರೆ, ಡಬ್ಬಿನ ತೆಗೆದುಕೊಡ್ತಾರೆ, ಮತ್ತೆ ಅದೇ ಜಾಗಕ್ಕೆ ಒಯ್ದು ಇಡ್ತಾರೆ. ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕೀಪ್ ಇನ್ ದ ಸೇಮ್ ಪ್ಲೇಸ್. ಸೊ ಇಟ್ ಈಸ್ ವೆಲ್ ಆರ್ಗನೈಸ್ಡ್ ಫಾರ್ಮ್. ಸೊ ದಟ್ ಈಸ್ ಇನ್ ದ organized form. If it is into the rack, they will ask you, they will access it easily, and once used they will keep it there itself. So this is called as a data structure. Okay, in simple terminology, data structure is well organized collection of data. So here there are different types of data structure. So just have the classification so that you can understand the different kind of data structure here. When it comes to the DS classification data structure, there is primitive and non-primitive. The primitive and non-primitive data structure. In non-primitive, you have linear and non-linear data structure. Okay, primitive data structure, it comes as int, float, double, okay, char. The linear data structure here, you are going to comes with the array, stack, okay, queue. So they are all linear data structure. If it comes to the non-linear data structure, that is, it comes with the tree, graph. Okay, so these are the non-linear data structure. This is the classification of data structure. So today we are going to learn the concept of stack. Okay, let's learn the concept of stack. Data structure which is non-primitive linear data structure. So what is stack? Let's take a stack. Assume the idli cooker. Okay, very simple. Idli cooker. How that is? That's to be traced here, and the plates are given here in this way, right? This is the now. So assume that this is an idli cooker where can I remove this plate? Can I remove below plate without removing the above? No, it's not possible. Not possible at all. So how I have to insert? While inserting also, say this is a tray 3, a tray 3, this is 2, this is 1. Okay, first I have to place tray 3, then only I can place 2, and then only I can place 1. So this placing insertion in a stack is called push, and bringing out is called as a pop. Okay, in stack, these are the terminologies. If nothing is there in this cooker, then that status is called -1. Hence, this is called as here as a top of the stack. Okay, so let's understand here. Hence, what is the logic or what is the concept behind this is inserting at first. What you have inserted here, I will just show here. This is your stack. Okay, so insertion first 1, 2, 3. Assume that. Okay, so first insertion is being done, but pushing here, whereas popping here. This is pop. Nothing, that is -1. Top is equal to -1. Okay, so what will happen? First you are inserted. First inserted. Now here popped. Pop, what happened? 3. Okay, so I will take a representation. It's very clearly. So assume that here, this is 1. I have pushed. Second, I pushed 2. Okay, next I have pushed the element 1, 2, 3. That is push 3. So how the pushing is happen? First 1, next second, next third, and so on. Now, if I want to make a pop, now what is the status of the stack? Status of the stack is 1, 2, and 3. Pop it. Which element first will delete? 3. Next, the stack stage is 2. Then if I say pop, which element is deleted? 2. Then again if I want to delete, the which element will be popped? 1. Okay, so what happened here? How it is? The reverse order of insertion. Stack works in reverse order of insertion. Reverse order of insertion is the deletion. Insertion is the deletion. Okay, that means that the first element is inserted. Here, what happened? The first element is inserted, lastly removed. Means first in, that concept, what that mechanism is called? First in, last out. That is FILO. The element which is inserting first is removing last. Or we can say that this is the last element which is inserted first. Last in, what happening? The first out. Okay, last in, first out. So this mechanism is called philo mechanism, or this is called LIFO mechanism. Stacks work with the concept of LIFO or philo mechanism. That is, last the element is inserted, first it will be removed, as it is a idli cooker. So how it is to be? Now this is a stack. Initially, what the value? No value in this. No value. How it is to be represented? That we are going to take the counter. The counter, that counter is called top. It is initially with -1 because nothing is there in the stack. In this stack, nothing is being placed. So hence that initial stage is called -1. This -1 represent the stack is underflow condition. What is this? It's called as a underflow condition. Stack is at a underflow. Example, you can take another here. Take the water bottle. Okay, what you are doing? You have taken the water bottle. Okay, now in water bottle, if it has a maximum size, say assume that it is 1 liter water bottle. Okay, in 1 liter, it is full. Now I want to pour some more water in that. What will happen? It will overflow. What will happen? It will overflow. Means, what is the maximum size? If that reaches to the maximum size, then that condition is called overflow. If assume the same water bottle and I am asking for the water, but this is empty. The bottle is empty. If the empty condition is called here what? Top is -1. If top is equal to -1, that condition is called underflow condition. Okay, so I hope you are clear. So if the top reaches to -1, there is no elements, that is called as a underflow in the stack. If it reaches and you want to pour it again, so what will happen here? Flow outside. The water will flow outside. So this flowing of outside is called as the overflow condition. When it reaches that when top reaches to -1, that is the underflow. When top reaches to maximum size -1, then that is called as an overflow condition, and this is a stack representation. Okay, so let's take what are the ADTs here. What are the operations we can perform on the basic ADTs on stack? What are the basic operations you can perform on the stack? Okay, so the stack, it is a representation where n equal to 3, 0, 1, 2. This is the stack as with the, okay, so here taken the n value is 3. Initially, we are assigning top is equal to -1. When it comes to the basic ADT, first we have to see that whether it is empty. Now, what is this condition is? Empty. That is, empty means under flow. Empty means under flow. So, the first thing, first method itself, you have to see that is empty. Okay. Now, if n equal to 3, that is 1, 2 and 3, the elements, it's n is 3. 3 means one more I have to take, the 4, because indexing starts with 3. So, n is equal to 3 here. Top reaches to the maximum size. What is that maximum size? N equal to 3. Max size. So, if this reaches, then that is called is full. stack is full, then that is called overflow. What this is called? Stack is, then that is, if it is full, then it is called, its condition is called overflow. If it is empty, then this is called underflow. Okay, fine. Next, if it is a underflow, if the condition is underflow, that is top is equal to -1, then this condition is called underflow. Then you can perform the operation called push. What you can do? Push means insertion is possible. Insertion is possible in stack. Okay. Now, fourth, if top reaches to the maximum size -1, what happen? Top reaches to the maximum size -1 means what is that? Is full. If it is full, then you cannot insert the element. But if it is full, what you can do? You can pop the element. It's possible to delete the elements. Delete the elements from the stack. Next is you can display. You can display. That is traverse the elements in the stack. How? From where it should start? The indexing should start from I will be given to the top where I is given to the top until where it should reach to -1. That condition is where it should reach. It should reach to -1 and I is going to decrement every time. Top need to be decremented by every time. Hence, we can display the stack of top value or stack of I value. You can go with either you can give the I or either you can give the top. How the we are going to take into the programming. So these are the basic editors. So let's understand how the push will happen, how popping can be done, how display operation can be performed in the stack by taking the model so that we can understand it easier. So let's take the first is pushing the elements into the stack. What we are going to do? We are going to push the element. So if pushing the element means we need to assume that there is a stack is a variable which contains the size, okay, max size, as we are going to take here macro. So here I have defined the macro with the hash define max size. Max size is 10. Okay, what we have taken? Max size is equal to, as it is a macro, we should not have any semicolon or nothing, space. Okay, so that max size is replaced by now. Okay, and assume that this is of the integer. Now we are going to take the size I and counter I, n is the size, and we are going to initialize the top is equal to -1, which represents the underflow condition. What it represents? It represents underflow condition. And the stack size is 10. So what is your stack size is? 0 to 9. That is n is equal to n minus 1. That's the max size. Maximum size is n minus 1. Okay, fine. So now pushing the element, we want to push the element. So method is I'm not taking integer or the thing, I'm just passing the void push. Okay, so I will ask the user to enter the value. So before that, what I have to say, whether it is full, I have to check because I want to insert the element into this stack. Okay, I want to insert the element into the stack. If it is already full, what will happen? Overflow. So I have to check that. Whether my stack permit me to insert the element, then I have to check the condition. What that condition is full. If I want to take the thing, that is if for the top it has reaches to maximum size. Okay, top has reached to max size -1 because induction starts from 0, hence we have to take with the thing. If this is the thing, what we have to display? Printf, this condition is called overflow. Okay, overflow. This condition is overflow. You cannot insert the elements if it reaches already to the maximum size. Otherwise, else. What you can say now? You have to else part. Now we are going to go with a block that is printf enter the element into the stack. We can enter element into the stack. That is scanf %d. One more what we need? We need as the element here. Int element. I have to read. So %d percent of element. Okay. Once you read the element, now here top is initially where? Top is assigned to -1. Now it need to increment by 1. That is top is equal to top plus 1. That means top initially is -1 and plus 1, that becomes top equal to 0. So the top is incremented and it comes to the 0th element. So first once I read the element, I need to increment top equal to top plus 1. Now the stack of top is incremented, the top hold to the place, the indexing value is 0. Now the stack of top, what is the variable for this? That is stack. In stack of top, we are going to give the red element. So that is element is to be added. Now once it is added, then now it is incremented, the stack of top, we have given the element. Hence this is the insertion. And if you want to print, what is the stack element? If you want to print the element, then you can print this time what the element is inserted. Element inserted is, okay, that is stack of top. The stack of top element is being inserted, and this is the close of the else part, and this is the close of the push method. So this is very easy to understand the push operation into the stack. Thank you.